Hey everybody, welcome to Systems Expert. Let's jump into the solution to this question.
Hi, Clement. In this interview, I want you to design the AlgoExpert website.
Okay, AlgoExpert. So the AlgoExpert.io website. At first thought, the AlgoExpert.io website seems like it covers a lot of different things. There's the homepage, the purchase page, the questions list, the code execution engine. Are we designing the entire platform or just a particular part of the platform, like the code execution engine, for example?
I want you to only worry about the core user flow. So nothing about the payment system or authentication. You can just assume that these work out of the box. Specifically also because we use third-party systems like Stripe and OAuth too. So you don't have to implement those.
Okay, so the core flow meaning a user goes on the website, they probably see the home page, then they go in the questions list, they can click on questions or mark them as completed, and then type code and run code on the platform?
Yeah, that's right.
Okay, cool. So if we take that as the main system or part of the system that we're designing, the first thing that I want to try to better understand is the type of availability that we're looking for in this system. My guess is that AlgoExpert isn't, a super critical life and death type of system. We probably don't need to shoot for the highest type of availability. That being said, of course, it is a paid product, so I'm assuming there is some expectation of availability. I'm thinking that we can probably shoot for somewhere between, I don't know, 2 and 3 nines of availability. Does that make sense?
Where does that get us in terms of like downtime per year? Can you give me like a number of hours or days every year that we would kind of have as a buffer?
Sure. So I'm thinking that since this is a paid product, we do want some level of availability. That's what I was trying to get across there. So I'm thinking, if we're going for 2 to 3 nines of availability, probably anywhere between 3 days of downtime at most, but at least 8 hours of downtime, because I'm thinking we might have issues. We're relying on third party systems like Stripe, you said, or what was it, OAuth. There's also, I think, the videos, which we're not going to be hosting ourselves. We're probably going to be using Vimeo, I think, or YouTube. So we're relying on third parties. So I'm thinking anywhere between 8 hours and 3 days at most. Is that acceptable, or should we be aiming for something better?
I think that's reasonable.
Okay, cool. So that's going to be the kind of framework that I'm operating under. Mainly, it means that I probably won't be making any extreme optimizations in favor of availability, to shoot for high availability. But so that's just what I'm keeping in mind there. The other couple of characteristics of the system that I think are obviously going to be important and maybe particularly important for AlgoExpert are latency and throughput. I suppose that for most of the website, latency and throughput actually aren't going to be particularly important. We're just going to expect, normal, relatively fast website. But for the code execution engine, which is very interactive, users are actually running code and they probably have an expectation of speed, or they want to see their code, the output of their code really fast. We're really going to care about latency there. So does that make sense that we would want to focus for latency, especially on the code execution engine?
Yeah, I think so. I agree.
And so as far as like how fast we want the code execution engine to be, I'm thinking like if I were a user on AlgoExpert, I would expect a reasonably fast, run code kind of functionality. Probably I know that it would be done on the internet, so I don't expect it to be instant, but almost instant. Anywhere between, I'm thinking, 0. 0.5 seconds to 4 seconds. Let's just say we're gonna shoot for 1 to 3 seconds of latency for the run code, and we'll see if that kind of falls apart later on when we actually get into the implementation of the design.
Okay. Yeah, let's do that.
Okay, so I guess I'll write some of these things down. I'll write that we are shooting for 2 to 3 nines of availability, and I'll say that we're shooting for normal latency for the website, and by normal I just mean what you expect on a normal website, just speed. But then for the run code, I'm actually going to quantify that and say 1 to 3 seconds or let me undo this S and write it like this: 1 to 3 seconds for the run code. And then I guess, what type of scale are we expecting for this website? Are we like, how many customers are we building this for? How many users at a given point in time?
Right, so we're going to be building this roughly at AlgoExpert scale. So AlgoExpert's website receives about a few hundred thousands of users every month, and you should be able to scale your design to support thousands of users at the same time.
Okay, so thousands of users basically at any point on the website. So maybe, tens of thousands of users at any point in time.
Yeah, that sounds right.
Okay. Okay, so I'll write that down. I'll say, let's say, 10 10K plus users at any point in time. So this is going to be concurrent users. And the last question that comes to mind before we can probably jump into some high level design, some high level, actual design is: are we serving only customers in the US, or are we serving a global audience, serving specific regions?
So that's a great question. We want the website to feel responsive to people everywhere in the world. And specifically to AlgoExpert, the US and India are the top two markets for us.
Okay, so we have a global customer base, but we're specifically like, probably we specifically want to optimize for US and India as regions.
Yep, I think that would be
Okay.
probably a great design would take that into account for sure.
Okay, so I'll write that down then. I'll say just US and India are kind of like our primary customer segments where we might want to optimize some stuff. Okay, so from a high level point of view, as far as the design goes, here are where my thoughts are at. The website is not just a static website. It has some static components to it, like the home page and just the general, JavaScript, the JavaScript bundle. But it also has quite a bit of dynamic content. First of all, users have to purchase the product, and then once they've purchased the product, even though we're not going to get into the purchasing, service, but once they've purchased the product, they have these questions that they can actually like mutate, or rather they can save data on the website, right? We want users to be able to save their solutions, you said, right?
Yeah,
Okay. So that means that we're definitely going to need a robust API behind the website to kind of power the website, and we're going to need a database to back that API, because we're going to be storing data, not only the static data, but also data pertaining to users, like their solutions, their code solutions, I guess their completion status of questions, we said. So the way that I'm thinking of dividing this design, or rather this plan of attack of the design, is first dealing with the static UI content, the static content for the user interface. Then maybe dealing with some of the auxiliary services that we have, like auth and payments, which I guess I'll probably skip over that step, but that would be my natural second step, these auxiliary services. Then maybe dealing with the core user actions related to seeing questions, typing code, seeing their own solutions to code or to questions. And then finally, the fourth part would be the actual running code on the website, like the code execution engine, I guess is what we can call it. Does that make sense as the four kind of steps?
yeah, I think so. So which one do you want to start with?
So I'll start with the UI static content, and I guess I'll write them down probably as I go. But UI static content, then auxiliary services, which I'll skip because we don't worry about payments and auth, then core user actions, and then actual running code. So for the UI static content, This is stuff like the home page, the JavaScript bundle, like I said, all of the images that are on the website. There are quite a few icons on the website, and just generally speaking, we can expect to have images on websites. Um, what I'm thinking for that is we can store static content in a blob store, like Google Cloud Storage or Amazon S3. So I'm actually going to write that down up here. I'll say for UI static content, we are going to store in, I'll just write blob store, I guess. Blob store. And here I'll put GCS for Google Cloud Storage, which is a blob store that I'm familiar with, or Amazon S3. And since we said that we really care about US customers, North America customers, as well as India customers, what I'm thinking is we might want to use a CDN for the static content to actually serve the static content, because the homepage is important, right? The homepage of the website, you want people to go on it and have it be very responsive. So I'm thinking that a CDN like Google Cloud CDN, which is again another CDN or another product that I'm familiar with, or I think we can use like Cloudflare, one of those CDNs to serve the static content, and that would be good because basically like the CDN would have its own servers, in India or near India in the US, and we would serve static content really fast, and that would probably reduce the response time of the home page or of the purchase page quite significantly for all users, regardless of their region. Does that make sense?
Yeah, yeah, no, that's great.
Okay, so then I'll actually write this down. So we said it's stored in a blob store, and then it'll be we'll have a CDN to serve it, CDN to serve, and here I'll put Google Cloud, so GC CDN. GC CDN will be Google Cloud CDN, or I guess Cloudflare. So Cloudflare. So this is what I'm thinking for the static content. And again, just to repeat one last time, this is going to be JavaScript bundle, any assets like images, that kind of stuff. I think that's probably as far as I need to go for the UI static content. Um, the next part, we said we would skip over the auxiliary services. So I'm just going to assume that authentication and and payments are taken care of. Though I suppose this next part that I'm thinking about, which is going to be like the life of a request kind of to AlgoExpert.io, will involve a little bit of auth and payments, but I guess because the first step that I'm thinking of going with now is load balancing, right? Like when a user gets on the website, gets served the static content, but starts hitting the actual AlgoExpert API. They get served the static content from the CDN, but then they actually hit the AlgoExpert API. We're likely going to want some kind of load balancing. And since we said that we cared about the regions so much, like US, India, etc., I'm thinking that a DNS load balancer right off the bat would be a good approach. So basically, like wherever a user is, depending on their region, we're going to have a DNS load balancer reroute that user's request to a cluster of servers in that user's given region, and we would probably have two or three major hubs, like one in North America, one in India, and one in maybe Europe if we think Europe is an important region. Does that make sense?
Yeah, yeah, I think that's great.
Okay, cool. So I guess what I'll do then is I'm actually going to draw something out. So I'll have a couple of circles. These are going to be, different clients. So for instance, the top one might be a US customer or US client, and the bottom one might be an India client. And these two clients are going to, issue requests to AlgoExpert.io. There's going to be first, the DNS load balancing that happens. And then depending on their region, their requests are going to be, routed to two different clusters of servers. So I'll route one up here and one down here. And I suppose here, like, it doesn't matter which one is US, which one is India. They're both essentially equivalent, but What matters is that they are different in different regions. And what I'm thinking is that once we've once the requests have been load balanced or distributed rather according to region, we should have another layer of load balancing based on the types of requests that they are. Because if you take a step back and you look at AlgoExpert, there are a lot of seemingly isolated services, and you can correct me if you think this is a bad direction, but the code execution engine, for example, is very different from the payment service. It seems like it's something that should be like they should not be, this they should not influence each other. So I'm basically thinking of doing some kind of path-based load balancing at the regional level, depending on the type of API call that you're making. So let's assume that the AlgoExpert API looks something like this, like slash API slash I don't know auth or slash payments or slash code run code or code execution or whatever. Depending on this path at the region level here, there will be another set of load balancers or another rather set of load balancing that redirects or distributes these requests. Do you think that makes sense?
Yeah, let's do that.
Okay, cool. So then here I will add a few sets of load balancers that basically do this path-based load balancing. So I'll probably just write down here path-based load balancing LB, and here I guess I'll put DNS LB. And I might give myself some more space in a little bit, but for now, let's just continue. And I suppose that even past the path-based load balancing, we can probably assume that here there are like multiple servers per path or per backend service, like multiple servers handling auth, multiple servers handling payments, and we could do even a further round of load balancing, like round robin load balancing for those servers. But I'll just assume that that's almost like captured in the path-based load balancing, okay?
Yeah, that makes sense. Let's do that.
Okay, cool. So once we have that, I guess now I'll probably write, I'll write here, or I'll keep the yellow color, but I'll write arrows that point to our application servers. We've got a set of application servers that are here, and these application servers are going to be basically, doing the logic. Like, oh, you're making a request to make a payment, they contact the third-party payment service. You're making a request to run code, they contact whatever we're going to design in a little bit. One thing that I'm thinking is for certain parts of the platform or for certain API requests, there is an access control point of view, right? Like if you own AlgoExpert, if you've bought the product versus if you haven't bought the product, the server should handle things differently. Like it should return a different set of questions, or like questions where you don't see the solutions or the videos yet, and so on and so forth. Is that correct?
Yeah, so how might it do that?
So I think we can do pretty simple access control implementation here, which would be just, the servers, your application servers make some internal API call to see if the user has permission or to see if the user has access to the product. And this might be some sort of like tag on the user account or something that's handled through the authentication and payment services. Like these two services would probably give the user the permission. But so these backend servers, I guess I'll just put an arrow for now. They point to like some other service here, which is like the ACL service that just says like it's just another internal API call. And once we have that, I guess that makes sense. Okay. Once we have that, what would we move on to next? I guess here we would start to talk about the actual, like what I called the user flow of accessing questions, like probably starting with the questions list and then individual questions. So are you comfortable if we move to that?
Yeah, let's do that.
Okay. So I'm going to move the screen a tiny bit here. when you think about the data on AlgoExpert, there are really two types of data. There's there's static data again, right? Because the questions list on AlgoExpert is static. It doesn't really change. Like the solutions that you write, the prompts, the question titles, and all that. But then there's also user data, like my solutions as a user, whether or not the question is completed. By the way, are we handling things like systems expert or like the data structures course on AlgoExpert or no?
Oh, no, so in terms of when you think about what kind of data we want to store, just think about the coding questions. And to simplify things, forget about user written tests even. Just think about the static content are solutions for every language, the completion
Okay.
status for a user for every question, forget about the ordering of questions. And then for each user has their own solutions for every language, and so we need to save that too.
Okay. Okay. So that simplifies a little bit. I think that even if we did have the other stuff, it would probably be very similar. But so I guess I stand by what I said of having like this distinction between static content versus actual user content, like their solutions. And so here I'm thinking that we can have two different types of storage then. We will we can probably store our static content, meaning the actual questions list, in a blob store again, like GCS or S3. So I'll actually write this up here. I'll put a database. Let's put it in blue, and this will be like blob store, and this has the static questions list. Okay, so I'll say static QL for questions list, and if a user requests like the questions list, what we would do is the request gets routed to application servers, right? The application servers do the ACL check. So I'll write one up here as well, ACL. And then depending on the ACL check, they request something from the blob store, or perhaps here we could have, they request something from the blob store, the questions list, then they make the ACL check and parse content out of whatever they got from the blob store. That might make sense as well. I don't think the ordering there necessarily matters. But what I am thinking is that we could do some caching here because the questions list, let's see, the questions list will get accessed a lot by a lot of users, and I guess it'll get accessed repeatedly by users. In one session, a user might go on the questions list like 3 or 4 times if they're doing multiple questions or if they're just exploring the website. So I'm thinking we could actually have 2 layers of caching to avoid having to make a bunch of requests to our blob store. So we will have one or a few requests to our blob store, but I'm thinking that we could do maybe at the client level right here. So literally like in the browser in our front end code, we could do some caching, some client side caching of the questions list. So when a client gets the questions list, they actually cache the questions list. So I'll put like a yellow dot here to show that we're caching, client side caching of QL. And then I'm also thinking that at the server level, at the application server level right here, we could also cache the questions list because the client-side caching would be just it would be better because a single client doesn't issue multiple requests in one session, and that means that the single client has a better experience on the website because they don't experience any latency the second or third time they request questions. But also here, if we have multiple people requesting the questions list, which is definitely going to happen, our server doesn't need to keep going to the blob store. So I'm actually going to put some server-side caching here. We can cache just like in memory right here for the questions list. Does that make sense?
Yeah. But is caching all of that data reasonable? And also, we might be updating questions every 2 days, say, but we kind of want any change to that static questions list to be reflected within the hour, for sure.
Okay.
So how much data are we talking about, and is this strategy actually reasonable given our refresh rate?
Right. Okay. So for the refresh rate, the fact that we're going to be updating the data, we can definitely implement some sort of cache eviction policy, and I'll get into that in a second. But first, let's just see if this is even reasonable. So estimating. Okay, let's say every question there are 85 questions. For the sake of simplicity, right now, I'm just going to round this up. So I'm going to do this more liberally. Round this up to 100 questions. We'll give an upper bound on how much data we're going to be caching or we might be caching. So let's say 100 questions. The question titles are kind of trivial compared to the actual solutions that we're saving and the prompt. Let's assume that we have 7 solutions for every language. Like a user saves, like writes code for every language. They also have the prompt, so that's like 8 big pieces of text. We said we don't care about the tests, but even if we did, that would double it. So let's just round this up to 10 big blobs of text. Let's say that a solution on average has, I don't know, anywhere between 1,000 and 10,000 characters or bytes of data. Let's go with 5,000. So 5,000 bytes of data per language. Multiply that by 10. That's 50,000 bytes of data multiplied by 100. That is,
Can you write that down?
yeah, I'll write it down. So that's 50,000 multiplied by 100. So that is 5 million. So 5 million bytes. So we're dealing with million. So 5 million bytes of data. So 5 megabytes of data. 5 megabytes seems reasonable in memory to cache in memory, no?
Yeah, 5 megabytes, 5 megabyte cache is really, really small. So that's absolutely no problem. Yeah.
Okay, and here plus this is an upper bound. Like I estimated that someone would write all the languages. We're expecting 5,000 bytes per language on average. So okay, 5 megabytes. Yeah, I feel comfortable with storing this in memory. So here I guess I'll write in memory caching of QL. Or not even QL here, I guess. Oh yeah, QL, yes, because we're talking about. Oh, I guess here I misspoke. We're not caching user written solutions, so I didn't overestimate that much. We're caching your solutions. So this is actually, I think, a pretty fair estimate, but I'm still comfortable with it. Even if this were like 20 megabytes, I'd be comfortable with it. So in memory caching of QL, we'll put. And sorry, I realize I'm running out of space here, but in memory caching, and then you said that we're going to be making updates to the questions. So yeah, you might be adding questions, you might be fixing bugs. That does seem important. You would want that reflected to users soon. So I'm thinking we could have a very simple cache eviction policy where we just invalidate and evict data from the cache every like 30 minutes, something like that. We just get rid of the 5 megabytes that are stored and reissue, the next request will reissue to the blob store and then come back and cache.
Yeah. Yeah. I think that makes sense.
Okay, cool. So then I'll just put here, 30-minute eviction policy. Okay, so I feel pretty comfortable with this, but this is only the static content. This is, like I just said, I corrected myself here. We're dealing with a static questions list. We're not talking yet about the user solutions, like the user created content, so to speak. So let's actually jump into that. We're going to need, I think, a more structured database for that because a blob store is fine for static content, but here we're probably going to be wanting to query this content a lot. I'm thinking we're going to go with a relational database for this. We can probably go with, I don't know, PostgreSQL for storing user metadata. And I'm going to call this, I guess, user metadata, just user created content. I'm thinking that we may want to have two tables, two primary tables. One that would be like question completion status, and one that would be question solutions, because those are kind of two separate flows on the platform. Does that make sense before I dive into the actual rows and columns of those tables?
Yeah, yeah. Let's look
Okay.
at question completion status first.
Okay. So I guess I'll put this database here. This will be PostgreSQL, so Postgres or just Postgres, and we'll have two tables. So let me give myself a bit more space. The the completion status I'm thinking will be, it'll have like a bunch of rows. Every row is a question, and so it has a user ID. So I'll put UID. I guess it has also an ID field for the actual row. So I'll put that here, ID. But then we have a user ID. This U stands for user ID, and I'm assuming we would get that from from our auth service. Then it has, I guess, a question ID. So this would be like QID, and then it would have like a completion status. So I'll put C status. And this for completion status, I think right now in AlgoExpert we have like able as users we are able to put complete, in progress, not complete. So basically this would be like an enum, right? This would be an enum of strings probably. And yeah, this seems like a reasonable table. That means that this table would be like we would have every user would have 85 rows in this table.
Okay, but so it looks like for every user, for every question, you're going to have a row. And given the fact that people can mark questions as complete or not, even if they don't purchase, we might have many, many of these rows. This table looks like it could get really, really large. So do you think it would be fast to get the completion status of a user for every one of his questions?
I think you're right here. Like it might be a little bit slow to sequentially go through the entire table. So what I'm thinking is we could index this table on user ID. So we could, this would be we're not like writing to this database is going to be just when a user marks a question as complete or not, and that's something that where we don't really care too much about the increased duration of the write to the index. So I'm thinking we can add an index on the user ID for this table.
Yeah, I think that would totally fix the performance issues. Yeah.
Okay, so then I'll put index here, and then we're gonna have a second table, which is gonna be for the solutions. So this table would be, I guess, again like rows. The rows would be, what would they be? The rows would be per question again. We would have an ID field, we would have a user ID field, we would have a question ID field, and then we have languages, right? So we would have a language field. So I'll put lang, and then I'll extend this and have a solution. So here, I think on this table, we would actually have 85 multiplied by 7, because there's 7 languages on AlgoExpert, right on the homepage. It says 7. So 85 multiplied by 7 rows per user. So that's almost like somewhere between 600 and 700 rows. I think we can, similar to this, like you suggested having an index on the user ID. I think we can index this table on user ID and on question ID, because we're gonna be going on individual questions a bunch, right? So yeah, I'm gonna add an index or two indexes here. Does this make sense?
Cool. Yeah, it does. It does. And so I assume that in your design, you'd basically be like giving the solutions for a specific question and a specific user, but for all languages back to the UI at the same time.
Yeah.
How does that change if we start adding, if we have like 20 languages instead?
I guess if the languages become too large, you may not want to do that. So what you might do is I mean, if you only have 20, it still doesn't seem like it's that much to sequentially iterate through. You might add an index even on the language at that point. Um, Also keep in mind that we can do some client side caching for this as well. so that if a user visits the same question a couple times, it's already cached. But I guess that doesn't really matter. We're certainly not going to be doing server side caching because users don't share any data. Like it's not like the static content where they do share the data. Here they don't share the data. But yeah, I guess to answer your question, I think we could add an index on the language if we think that we're at a point where we have a lot of languages and it warrants having an index.
Okay, yeah, cool.
Okay, so then I think this is it for the data model. As far as like actual, making the right requests to the database, obviously our application servers are going to be making these requests. So, here they're going to go to the database, and this is going to happen every time that a user either checks off a question as complete or marks it as in progress, or whenever they're typing code. So, I do believe that we would want to what's the word, debounce? Yeah, we would want to have a debounce on the UI when you're writing code to not issue write requests, every like 0.5 seconds or whatever. We would probably have like a 2 to 3 second debounce, and I think that seems reasonable. Like if we said that we expect to have like, let's say 10,000 users on the platform at once. So 10,000 users, let's say that 80% of them are typing code on the platform. So 8,000 of them, and they're all typing at any given point in time. You might expect that we would have, or like in 1 second, we might have, I don't know, 1,000 requests happening if we have a 2 to 3 second debounce, and 1,000 write requests per second seems very reasonable for a database like Postgres. What do you think?
Yeah, but does that story change with the regions that we
Oh,
have?
yeah, so for the regions, I guess I should have mentioned this because we're still, remember, in our design here, we're still dealing with separate regions. So like maybe I should write this. I'll write this as I'll write it in white here. This is India, for example, and this is US or North America maybe. And India might serve Southeast Asia or something, and we might have another cluster for Europe. And I think we would have multiple database servers. So here there would be another database server, and these servers would be going here. And what I'm thinking is, so on any particular database server, I think we can handle the amount of writes that I was talking about a second ago. But do we want these database servers to be in sync? Because like the reason we have multiple database servers here is because we want this database server to be close to India so that India customers have low latency, and same for this for US, right? But users, like a US customer will never access an India customer's data. So US customers should never hit this database unless, of course, the US customer like travels to India or travels to a region that does hit this database. So I'm thinking that these two databases, like we need to have some kind of asynchronous replication, but it doesn't have to be synchronous. It doesn't have to happen immediately. So to clarify, if a US customer is making a write request to this database, we will make that write request and that's it. Maybe we'll have some redundancy here to make sure that, if this database goes down, we have a backup, a standby. But as far as like our main database clusters here, like regional clusters, I think we could have some kind of, asynchronous replication here that happens, I don't know, every, I don't know, 6 hours. Because here we're trying to avoid the case where a US customer has all their data stored in the US database. They fly to India. They happen to go on AlgoExpert because they love the platform, and they don't have their data in this database. I guess that would be like really bad. It would be a very small edge case, but it would be bad. So I'm thinking async replication every like 6 hours, 4 hours. Does that make sense?
Yeah, I think 6 hours is plenty enough. It probably won't happen that often, and the flights are generally pretty long, and yeah, so I think that's fine. 6 hours should be okay.
Yeah, and plus I'm thinking that, this is something where, if we're optimizing the system afterwards and we have metrics on the system and everything, we can kind of like tweak this accordingly. But so
Yeah.
I'm thinking that we have almost everything here. I guess the big ticket item, the last big ticket item is going to be the code execution platform now, which I'm a little bit scared by because it seems like a daunting task. Like how much in detail do you want me to go here?
Yeah, I don't want you to think about the security aspect because it's not really like a distributed systems problem. It's more like an operating system problem, and so I don't want you to worry about that at all.
Okay, so I think what I'll do is I will think of just how we would handle like the actual requests, not the actual implementation of running the code or making sure that the code isn't like corrupt or something. So let's imagine that here, we have our path-based load balancing that's kind of off screen now, but this goes to some kind of run code server here. These red servers handle the running code. And I suppose one thing that would be important, kind of from a security aspect, I don't know if you didn't want me to take care of that, but I think we need to rate limit here because this seems like an obvious place where we would get like rate limiting or not rate limiting, but like requests abuse. Like people might try to bring the platform down by doing denial of service attacks. So I'm thinking of just putting some rate limiting here. Is that okay?
Yeah. I think that's fine. So how often do you think is fine from like a product perspective? How often should people be able to run code, right?
Well, so I guess like you want people to have a good experience, so you probably want them to be able to run code, at least once every second. Like if they want to run code a couple times in a row, so once every second or once every 0.5 seconds, that would be like the base rate limiting, I guess. More than that, and you throw an error. Um, Maybe we would want to do something a bit more complicated, like tier based rate limiting. So every 3 seconds they can only run code, or they can only run code like 3 times every 5 seconds, once every second, and 5 times every minute, because beyond 5 times in a minute seems like something weird is going on. Does that make sense?
Yeah. More than 5 times per minute, and they're likely like scripting something, right?
Yeah. So that's what I'm thinking of. So basically, like the idea would be rate limiting here, and I would make it tier based basically. And here I think that we can use a simple like key value store like Redis. So I'll put kv store like Redis to implement this rate limiting. Does that
Yeah,
make sense? Okay.
yeah. That's great.
Cool. So that's the first layer of defense. Then we're not taking care of the actual security related to the code, like you just said. As far as handling the traffic, what I'm thinking is that these servers, these application servers that are actually handling the requests, we don't want to actually have them be the ones running code. We want to have some other service running code. So I'm going to write here a couple of circles that represent, I don't know, let's call them code executioners or workers. And basically, our application servers here, let me give myself some space, but our application servers here are sending requests to these workers to run the code. And these are the ones actually running the code. And, I'm assuming that we would have some sort of, way for these servers to know when a worker is like in progress or when a worker is uh, resetting itself. We probably don't want these workers to reboot because that would take a lot of time. And remember, this is where the latency comes into play. We cared a lot about the 1 to 3 second latency aspect of the code execution engine. But so I'm thinking that these workers will still have a point in time where they have to they finish running code and they have to clean up zombie processes or extra generated files, and our application servers would have to know not to send another request to another worker that's in the process of cleaning itself up, or maybe there would be some sort of like queue based system. um, but the point is we would have these workers that would be handling the run code separately. And let me think, because I did say that the 1 to 3 seconds was important for latency. I feel like some languages like JavaScript and Python would be really fast because you don't have to compile them. Java or C++ might be slower because you do have to compile them. I'm thinking still on average, like this part of the process, this here could be like 2 seconds on average. And then you have like the additional requests overhead here, and we do reach that 3 second bound. And of course, we probably can optimize this. So I'm feeling kind of comfortable with this very loose design here. Does that make sense?
Yeah, that's perfect.
Um,
But so how many of those workers like do you expect to need given the number of people like on the website at all points in time?
so we said that we had what? We said like 10,000 people on the website at a time. Like that was my loose estimation earlier based off of your, tens of thousands in a day.
Yeah.
Um, then, 8,000 on the code, like actually typing code at a time. And then run code. You don't run code that frequently, right? You probably run code like 5, 10 times in an hour long session of writing code. So I feel like at any given point in time, you probably have, 8,000 divided by, I don't know, like 10, or sorry, by like 100 if you're running code that infrequently. I'm thinking you have 10 run code requests per second, anywhere between 10 and 100. And so I'm thinking that, you have the equivalent number of worker machines. So you might have 10 to 20 to 100 worker machines at any given point in time. And this feels like this is a part of our system that can scale horizontally very easily. Like you just add workers if you see that your traffic is higher. We can also scale vertically by giving them more resources, like more CPU. And I'm assuming that, by the way, that for these workers we can have a machine with, or machines rather, with 8 cores. Like we're talking about MacBook Pros here running code.
Or not necessarily exactly MacBook Pros, but yeah, something like 8 CPUs, and the actual compilation time should probably be closer to like a second or second and a half at most. So yeah, that estimate's pretty correct. It's pretty spot
Okay,
on.
but so I guess I'll just write for clarification here that, like, 10 to, let's say, 100 workers, depending on, like, you know depending on the traffic that you're kind of expecting. And
Yeah.
let's put it this way: horizontally scalable, horizontally scalable. I'm not sure if there are two L's to horizontally, but we'll go with two L's. So yeah, I think that's kind of what I'm thinking for the system. If I kind of go back to the beginning here, I think we've covered most of our bases. I will say that just as a bonus, I know we're running out of time, but as a bonus, like, we would probably want to have some pretty robust logging and monitoring in place here, especially for the code execution engine, if we want to keep track of how many users are running code at a time, in what language. Like here, I'm thinking that for our workers, we might optimize this basically based on our logging and monitoring, whatever the data tells us. We might even separate these workers out based on languages. The application servers might reroute or forward requests to specific language workers. But this would all come, as our system grows, and logging and monitoring could help with that. So that's kind of like a bonus that I'm thinking of if we want to really optimize this system. But otherwise, like, I think I'm feeling pretty comfortable with the system. Do you have any other things that you'd like me to cover, or?
No, I think we're pretty much out of time. But yeah, your point about the logging and monitoring is really good. That's probably how we would auto scale the number of workers ideally, so we don't have to do it manually.
Okay, cool. Well, thanks a lot.
Yep.
With that, I hope that you found this video informative, and we'll see you in the next one.